Hello and welcome to Group 5's presentation of our marketing analytics project on predictive modeling of customer churn. This project will be narrated by Team 5, which includes Manuela, Alexandra, Thomas, and Aspen. So let's start off by discussing the objective and problem we tried to solve through our project. The main objective for this project was to design a prediction model that accurately identifies whether a customer will churn or not from a telecommunications service. Our team was given a large real-world Excel dataset to base our prediction model on. The dataset was from an unknown telecommunications company in the early 2000s. It contained data from 3,950 customers along with multiple variables. It was our job to determine which variables were relevant to our prediction model and which of those needed to be eliminated. We made adjustments in Excel before we started using the analytics software RapidMiner. After cleaning and modifying our variables, we designed our prediction model and ran it through the RapidMiner software. For reference, churning is the act of a customer leaving the service of a company. Usually once a customer churns from a company, they are lost to that company forever. So the benefit of predicting which customers are more likely to churn is that it allows businesses to target these customers and improve their marketing efforts in order to retain these customers. So how did we go about creating our prediction model? We chose the logistic regression model to predict customer churn because it naturally calculates the probability of an event happening. We felt like logistic regression would be easier to interpret for this project, and it also is important to note that logistic regression models are one of the best when the dependent variable is binary, which our dependent variable of churn or not churn is binary. So we could not choose in the software whether we wanted our model to calculate the probability of churn or the probability of not churning. So RapidMiner automatically chose it based on the mode, which is the probability of not churning. Therefore, the predictor's coefficients from our final model are going to be predicting not churning probability instead of churning probability.
Here are the 7 final predictors that we chose to use in our model. I'm going to go over each one of them and explain why we chose to use them. 1-year mark is whether or not customers are getting to their 1-year mark with the service. 0 means that they're not at the 1-year mark, and 1 means that they are at the 1-year mark. We thought that if customers are near their 11 or 12 months mark, it would mean that they are more likely to churn, since it would be the perfect opportunity for them to quit the contract if they're not satisfied with the service. Number of calls to retention team is the number of calls that each customer calls the retention team. We included this attribute in our model because we thought that the number of times customer called to the retention team would be a great determinant on whether or not they would churn. We thought that customers who call the retention team more times would be more likely to churn. We decided to use credit score as a great predictor because we thought that it would be a great determinant of income, and we assumed that people with a lower income would be more likely to churn, so we wanted to include it in our model. Average overcharge is the amount in US dollars that customers are being charged by the phone company over the basic charge. We assume that if people are being overcharged high amounts, then they would be more likely to churn. Basic charge in quantiles are the recurring charge that each customer is paying divided into 6 quantiles. 1 are low base charges, and 6 are high base charges. We thought that customers paying high price for their phone service would be more likely to churn. Active rate was a variable created by us, which is the ratio between number of accounts a customer holds and how many of the accounts are actually being used. We believe that if customers are paying for more than one account but users are not active, then they would be more likely to churn. So below 100% on the active rate customers would be more likely to churn. Roam is the mean number of roaming calls made per customer. We assume that people that use roam were probably traveling more, so they would need a phone service more often, so they would be less likely to churn. On the other hand, if they use roam, they would probably be charged more for their service, which could lead them to churn. So that's why we chose roam, because we thought that it was very relevant to predict our probability of churn. Now we're going to focus on all the results from our final model.
Okay, so now I'm going to be talking about the relationship between predictor values and churn probability. For credit score, if the person has a low credit score, they are 0.279 times more likely to not churn. And for a medium credit score, they're 0.06 times more likely to not churn. So overall, people with high credit scores are more likely to churn than customers with low credit scores. Secondly, for the 1-year mark credit score predictor, customers who are achieving their 11 or 12-month mark are 0.723 times less likely to not churn. That means that people who are getting to the end of their contract are more likely to churn than people who are not about to approach their 11 or 12-month mark. Next is the retention calls predictor. As the number of calls to the retention team increases, the likelihood of not churning decreases by 0.025 times. For the average overcharge predictor, as customers get charged more than the base price for their phone service, the likelihood of them not churning decreases by 0.023 times. This means that when customers are overcharged for their phone service, they're more likely to churn by 0.023 times the overcharged price. Next is the basic charge predictor. As customers move up between 1 and 6 in the range of the amount they're being charged for the base service, their likelihood of not churning increases by 0.004 times. This means that as customers are charged more for their service, they're less likely to churn, but only by a very small amount. Moving on to the active rate predictor, customers that are near the 100% active rate are much less likely to churn, by 0.006. And lastly, the roam predictor. Customers that use their phones internationally are just more likely to churn. As the mean number of roam calls goes up, the likelihood of the customer not churning goes down by 0.067 times.
So now that we've covered each of the predictors within our model and how they affect our churn probability, let's move on to our results and our findings.
So what we are looking at is the confusion matrix. It tells us how much accuracy our model had and also how much error our model had. So our logistic regression model had 52.17% accuracy and 47.83% error. It is important to note that due to the fact that we used a logistic regression model, our model tended to predict non-churners rather than churners. Let's talk about how the confusion matrix also tells us the sensitivity and specificity of our model. The sensitivity of our model was low at 7.5%, while the specificity was high at 96.45%. This makes sense due to the fact that we built our prediction model using logistic regression. Logistic regression bases its prediction on the mode. This means that when it came to identifying non-churners, our model usually identifies them correctly. The trade-off is that our sensitivity is low at 7.5%, which means that our model did a poor job at correctly identifying customers that churned.
The graph above represents the predicted percentage of customer churn based on their credit score. As we can see, from all customers that have a lower credit score, our model predicts that only 16.79% of them will churn, while 83.21% will not. From all medium credit score customers, 36.47% is predicted to churn and 63.53% is predicted to not churn. People with a high credit score are overall predicted to churn more than customers with low or medium credit scores. It is predicted that from all high credit score customers, 47.66% will churn and 52.34% will not. Assuming that credit score is a determinant of income, we can reason that customers with a high credit score have more flexibility to switch to another company if they are unhappy with the service, so they are more likely to churn. The graph above illustrates the percentage of customers that are predicted to churn based on whether or not they are at the 11 to 12 months mark, which is when their contract will end. Based on the figure, we can see that 100% of customers achieving their 1-year mark are likely to churn. From people that are not at the 11 to 12 months mark, only 31.24% of them are predicted to churn. Comparing both, we can see that people achieving the 1-year mark are way more likely to churn. This might be due to the opportunity customers have to leave the company at the end of their contract if they're unhappy with the service. As illustrated by this graph, we compared the predicted percentage of customer churn based on various quintiles of recurring charges. Quintile 1 indicates those with lower amounts of recurring charge, whereas the 6th quintile is an indicator of higher amounts of recurring charge. In the first and second quintiles, we can observe that there are higher amounts of churners with 64.57% and 71.85% respectively. There is a notable decrease in churn percentage starting with the third quintile, which progresses up until the 6th. This could possibly be explained by the higher quintiles paying higher rates for reasons such as having more lines on their plan. It would make sense as to why there is less churn percentage because having more lines on their plan would mean that the decision to switch carriers would have to be agreed upon by more than just one person. Another possible scenario could be that customers paying higher rates on their plans could be getting more features with their service, which would increase their likelihood of being satisfied. More satisfaction equals less motivation to churn. The graph above illustrates the percentage of predicted churn based on the number of calls customers made to the retention team. Based on the findings, when customers call one time to the team, 97.41% of them churn, and after the second call, all 100% of customers that called churn. That might be due to having a customer service team that provides poor service, leading to further dissatisfied customers.
This graph illustrates the average in which customers are being overcharged for their service based on their credit score and whether or not they are predicted to churn. We are assuming that credit score is a determinant of income, and based on this graph, we can see that the highest average overcharge is given to low credit score customers or low-income customers. And the lowest average overcharge is given to high credit score customers or high-income customers. We can assume that customers who are paying a higher overcharge amount, on average, are more likely to churn. This graph represents the average number of roaming calls customers are making based on their credit score and whether or not they're predicted to churn. We can observe that customers with highest average number of roaming calls had low credit score. At the same time, the lowest average number of roaming calls were made from high credit score customers. We can assume that customers with a low credit score will be more likely to engage in roaming calls, and customers with high credit score are less likely to engage in roaming calls. Overall, customers are more likely to churn when they are engaging in roaming calls. This graph illustrates the average active rate and the prediction of churn. Active rate is the rate between the number of open accounts under one customer and the number of accounts that are actually being used or are active in that customer's account. This rate goes from 0 to 100%, in which 100 means that the customer is 100% active in their account, or 100% of open accounts are being used. From the graph, we can observe that customers who are closer to 100 active rate are less likely to churn. However, we can also see that the difference between the average active rate from customers who are predicted to churn and customers predicted to not churn is small, only 8%, which means that if customers are not as active in their account, they're more likely to churn, even if it is by a small percentage. Here is the overall type of customers that are more likely to churn. They either have a high credit score and a few other characteristics, or they have a low credit score and are being overcharged for their phone service, plus more characteristics. The other characteristics that the customer can have is that they are achieving their 1-year mark with the company, which is the end of their contract. They have called the retention team more than once. They have a low basic charge. They are less than 100% active in their account. And they have been using roaming calls more often. Now we're going over some business recommendations based on the overall type of customers and their likelihood of churn. First, we recommend the company to offer a higher price plan with additional service for customers who can afford it and are unhappy with their basic plan. That is because we noticed that high credit score customers or high income customers are more likely to churn. And we thought that the reason for that would be that they have more options and they can afford to change their service if they are unhappy. So a good option would be for the company to offer a better plan for those customers that can afford it. Second, we recommend the company to offer an international plan at a fixed rate for customers who engage in higher amounts of roaming calls and are being overcharged for it. That is because we noticed that customers who are more likely to engage in roaming calls also are more likely to churn if they are being overcharged high amounts. So we thought that if the company could offer a service that has international roaming calls at a fixed cost, customers wouldn't be surprised with the overcharge amounts because they would be paying the fixed rate. Third, we recommend the company to focus on customer service training of employees at the retention call center. That is because after the first call to the retention team, 100% of customers are predicted to churn. That is, if they are calling the retention team for the second time, they are 100% predicted to churn. That means that the customer service might not be as good in the retention call center, so that's why we believe that the company should focus on customer service training of employees and also offer maybe some other promotions when they are talking to a customer. Our last recommendation is for the company to offer a discount when customers renew their plan. That is because, based on our findings, 100% of customers achieving their 1 year mark are predicted to churn. That is, all customers achieving their 1 year mark are predicted to churn. If the company offers a discount or an incentive for those customers to renew their plan and stay with the company, that would make them more likely to not churn. That means they will be less likely to churn when they achieve the 1 year mark.
Next, I'm going to be talking about some limitations we experienced in our project. We ran into a little bit of confusion about some of the variables that we used in our project. All of them were means of different attributes in the project. To start, we didn't understand the mean number of blocked voice calls because we weren't sure if this variable was referring to the number of blocked calls due to poor service, limit of calling time, or from calling customer services. Another example of a variable we had difficulty interpreting was the mean number of unanswered phone calls because we weren't sure if the unanswered phone calls were incoming calls from another person or outgoing calls from the customer to the customer service center. Some of our variables also had missing data, so it was obsolete and we couldn't use it, and this affected the integrity of some of the conclusions that we came to. Lastly, we experienced time constraints to make a very powerful prediction model. Our process in RapidMiner could have been a little bit more efficiently developed had we devoted more time to this early on in the project. Next, I'm going to be talking about future steps. If we had had more time to do this project, we would have engaged more and tested all of our variables to see which ones were actually relevant. We also would have conducted a little bit more statistical analysis in the variables because we chose our predictors based on intuition. During this project, we found ourselves struggling at points because we overthought our process and made things too hard on ourselves and confusing. Specifically, with the process that we made for our prediction model, we could have just stuck to one or two. Since our random forest model had the highest degree of accuracy compared to all the others, we could have just stuck to that. Additionally, with more time, we would have streamlined the process a little bit more and excluded everything on Excel that wasn't necessary. In conclusion, we would have resolved the issues regarding the missing data that I mentioned just before and taken more time to resolve the issues with the highest level of accuracy for the conclusions we interpreted from our statistic analysis.
So now each one of us are going to talk about our main takeaways. Hi, my name is Manuela, and here are a few of my main takeaways for this project. One, it's time management because we could not leave to do this project last minute since we had to learn a lot about how to build a model on a new software and how to make it make sense to other people. I also learned a new analytical software, RapidMiner, which is very beneficial for my career in the future. And I also learned how to organize all the data and try to present it in a way that it's easier for other people to understand. So I think those were my main takeaways where I could actually see that I could use that in the real world in my career. And if I could give an advice for my past self, would be to start playing with RapidMiner before the start of the project because I didn't know how to use the new software until I actually had to learn it. So it would have been way easier to know how to use RapidMiner beforehand. And I would also advise myself to test other predictors so we could see which ones are actually relevant for the prediction model. Thank you.
So, this project and class as a whole has taught me the true importance of analytical thinking in the marketing field. Learning to use the RapidMiner software aided my understanding of developing predictive models and how these models are beneficial in formulating effective business marketing decisions. It was also great to further develop my skill set with Excel and learn how to manage big data. If I could give myself advice at the beginning of the semester, it would be to prepare ahead of time and introduce myself to new software before going to class.
Hey, I'm Thomas, and what I got out of doing this project was experiencing what it's like to solve a problem within an industry using software that's essential for modern day marketing analysts. Some of the skills I gained from this were learning how to use RapidMiner and its various operators, as well as how to build charts in Excel, which were translated from our RapidMiner process. This was primarily done using the pivot tools provided to us by Excel. And some advice I would give my past self is just to pay more attention to the many parameters within an operator, because if even one parameter is set wrong, it has the potential to affect our whole RapidMiner process. Thank you.
Hi, my name is Aspen, and these are my main takeaways for this project. The biggest one for me was time management, because this isn't a project that you can just push off until the last minute. The second one is that I learned I didn't want to go into a career field related to data analytics, which is good, because even though using the software for analytics and stats wasn't my favorite, it did help me realize that I'll excel in a more creative field when I'm looking for a job after graduation. This project forced me to look at marketing data through a logical and analytic perspective, which I hadn't done before. And if I could give advice for my past self, it would be to seek out more help for information regarding the RapidMiner software. There were several times when the program crashed repeatedly, and I couldn't figure out how to prevent this from happening. So maybe even having a backup device for this project would have been helpful for my situation.